Hello everyone, in this video we'll be solving problem 1935, maximum number of words we can type. The problem statement is we are given a string text of words separated by a single space and a string of broken letters. We need to return the number of words that we can type from the given text using this broken keyboard. In example number 1, the text is hello world and the broken letters are A and D. Considering there are two keys broken in the keyboard A and D, between the two words given to us in the text, we can only type the first word, that is hello, as it does not contain any letters that are broken. This is a very easy and straightforward problem. Let's switch to whiteboard and discuss how we can solve this problem efficiently. The simplest solution is to iterate through all of the characters in the given word and check if the character exists in the broken letters. If none of the character from the word exists in the broken letters string, then we can increment the counter. If the word contains any characters that exist in the broken letter string, then we'll skip the step of incrementing the counter. One optimization we can do to this approach is to choose the right dataset. As we need to do a lookup for each character if it exists in the collection, the best option is to use a hash set dataset as it offers the time complexity of O of 1 to do a lookup. I don't think it's necessary as the solution is pretty straightforward, but just for the sake of it, let's do a quick dry run on this example. None of the characters in the first word exists in the broken letters collection. So we can go ahead and increment our counter by 1. Moving on to the next word, the character D exists in the collection, so we cannot type this entire word as is. So in this case, we'll skip the step of incrementing the counter. After iterating through all words, we'll return the counter as the output. The time complexity of this solution is O of m into n, where m is the number of words given in the input and n is the average size of the word. Or I could also say the time complexity is O of m, where m is the number of characters across all of the words given in the input. This is because we need to iterate through all of the characters across all of the words to check if it exists in the broken letters collection. While the space complexity is O of k, where k is the number of characters in the broken letters string. This is because we are building a collection with all of the characters that we received in the broken letter string. I hope you are able to understand the explanation. Let me show you how we can implement this using Python. In this Python implementation, I start by initializing a broken set variable which is of type set and adding all of the characters in the broken letter string. After that, I've initialized one more variable called count to store our output. On the next line, I'm starting a for loop to iterate through all of the words in the given text, and inside that I have one more loop to check if the characters in the individual word does it exist in the broken set. If yes, then we'll skip the step of incrementing the count variable, and if not, then I'll increment the count variable. Once this for loop is complete, I'm returning the count as the output. This code, when submitted on LeetCode, beats nearly 15% of the submissions in terms of runtime and 14% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.